Hello, everyone. This is the lecture for section 1.7, inverse functions. So at this point in chapter 1, we've been dealing a lot with functions, just regular good old functions, right? I showed you a bunch of them that we're going to be seeing on a regular basis, right? Now we're going to try to cover what's called inverse functions, right? So first thing I'm going to do, define it like I usually do, okay? Give you guys a couple of examples of inverse functions, right? And then go through the nomenclature and all the little bits that we've been doing just for functions. So domains, ranges, right? And tying up sort of like a little loose end that happens because of inverse functions, okay? So let me define what an inverse function is, first of all, right? Okay. The first thing is that any one-to-one function, right? Remember what a one-to-one function was, right? If you have a one-to-one function, you automatically have an inverse, okay? And what does an inverse do is exactly sort of what you think it would do. An inverse of a function undoes what another function did, okay? So the two properties, right, of an inverse function is this one, and this one, okay? And both of these are going to equal x. Okay, so we know how to, the composite function, right? This right here on both of these is the composite of f and its inverse, okay? And they do exactly what you think they do, okay? Basically, f cancels its inverse and the inverse cancels the function. Does that make sense? And all you get left with is f, okay? So these are the two conditions that make an inverse function. Okay, now, I have to state this, right? The actual definition is that both of these have to be correct, okay? We are not far enough along in math to find functions where one works and the other doesn't. So you only need to check one of these, okay? Either one is fine. It doesn't matter. I'll show you guys when we get to the examples, right? Okay? All right, so something that I need to sort of clarify here, right? Is the notation. So hopefully you guys see this, right? Okay. This is not the same as this, f of x, okay, to the -1 power. Those two things are distinct, okay? This just so happens to be sort of like a thing in math that ended up happening. Nobody caught it and we just ran with it. We're like, all right, we just have to warn people, right? When we get there, right? So this, hopefully, maybe you guys remember this from like high school. This right here is getting into exponents. We haven't done exponents yet, so that's going to be our chapter 4, right? But if you remember, these are exponents. We can have a -1 power, but, right? These two things are not equivalent. These two things are different, okay? So just keep that in mind, all right? Okay. So I've got a couple here, a couple of inverses or a couple of functions that I want to put down as inverses, show you guys how these are supposed to work a little bit, okay? So suppose for the first one, right, let's say f of x, right, is 2x, okay? So then that means, right, that if we plugged in 3 into our x for f of x, right, then that means that the output is going to be 6. That's supposed to be our y value, correct? Write that in the middle, right? Since the function grabs my input, my x value, in this case 3, it's going to grab it, multiply it by 2, right? And it'll give me 6. All right, cool. So now, what the heck does the inverse do? Okay, the inverse is supposed to flip what the function did, right? So in our case, right, I should be able to an inverse function, give it 6, and it should give me 3. So basically, these two flipped. Got it? Okay. But it should do it for everything, right? Okay. And the inverse for this one, the inverse for this function, for this f of x right here, for f of x equal 2x, this one, the inverse is going to be x over 2. Okay, now it should sort of make sense, hopefully, right? That over 2. That the function grabbed the input, multiplied it by 2, right? So then the inverse should grab the output from the other one, right? And divide it by 2. That'll undo it, correct? There we go. Okay, let's move on to the next one. F of x equal x divided by 3, right? So if I give f of x 12, right, then f of x is going to divide it by 3. My output should be 4, right? 4, let me draw that nicer. There we go, 4, okay? So then equivalently, right, I should be able to give the inverse, the 4, the output from f, and it should give me 12. And it should be able to do it for everything, right? Does that make sense? Right? And hopefully you guys see the role here, right? F of x divided by 3, right? So then f inverse, the thing to undo it, should be multiplying by 3. And lo and behold, the inverse for this would be 3x. That simple. Okay? Let's get to some harder ones. Okay. The square root function. Right? Okay? So let's go ahead and do an example here. Let's say, right, for the square root, I gave it 16, right? And the square root is going to give me 4. So this is going to be the input and output for f of x for the square root function, correct? All right, cool. So the inverse function should do the opposite. I should be able to give this thing 4, and it should give me 16. Okay? Now, the square root function square rooted whatever was inside the x, right? So thinking about it a little bit, right? If f of x square rooted it, then maybe the inverse should square it, right? All right, cool. And lo and behold, right? The inverse for this one is squared. Now, I'm going to highlight this in red because this is actually going to be a problem, okay? And this is the problem that we have to clean up at the end of the section, okay? Let me actually make that squared a little nicer to read, huh? X squared, there we go. So this one's the one that's going to be a problem we had to clean up before the section is done, okay? Next one. Okay, x cubed. So we know what the cubed function looks like, right? It grabs our thing and cubes. So for example, if I put in 2, f of x is going to give me 8. So it's going to be 2 times 2, that's 4, times another 2, that's 8. Okay, so the inverse should do the opposite. If I give it 8, it should give me 2, right? And lo and behold, this one does have an inverse. X, and this is going to be called the cubic function. The cube root function, okay? So it basically undoes the cube that f of x does, right? Okay, so now, let's go down to the very last one, okay? This one, f of x is equal to the absolute value of x. So then if I give this -3, right, the absolute value is going to spit out 3. Got it? So same thing, I should be able to give it 3, and this thing should be able to spit out -3, the opposite of these, right? Okay, now, does everything have an inverse? No, it does not. Everything does not have an inverse. This one is one of those that do not have an inverse. So we just say for this one, does not exist, okay? And it does not exist primarily because of this property right here. A one-to-one function, f of x has to be one-to-one. You guys recall what the absolute value graph looks like, right? Horizontal line test in particular is what you're going to need. Absolute value of x does not pass one-to-one. It does not pass horizontal line test. So this function is one of the many functions that do not have inverses. Okay, you're not guaranteed an inverse every time. Okay, this is one of those examples. All right. Okay, so now let's get into some nitty-gritty. Okay, how to determine whether two functions are inverses of each other or not. Okay, in order to do that, we need to grab one of the functions and stick it into the other. So determine if my f composed g is equal to x, and determine if g composed f is equal to x. So in practice, at least at this level of math, you just need to check one of the two, not both. So either one or two. Like I said, at this level of math, checking one will suffice. The only time that you're going to need to know if both is if, and I'm already going to state this, I'm probably going to say it a bunch of times. If you ever need to study math for the rest of your life, then you need to satisfy both. Okay, but that'll be later. Your instructors will tell you when to check for both. Okay. Okay, but now suppose you were given two functions and you had to determine if f of x, right, and g of x are inverses. Okay, these are the two conditions that you need to verify, either that one or the one below it. Okay, and it doesn't matter which one. Okay, so let me show you guys how this works out. Right, this is a composition of functions, so I need to grab, and I'm going to do this in this case, right? I'm actually going to do both, just for completeness sake, right? I have to do f composed g of x. So I need to grab all of g and stick it into f, just like we did in composition, right, in the previous section. So this is equal to 1 over, okay? You guys see how this is my x? All of this has to be all of this. So here we go. This is going to be 1 over x minus 2 plus 2. Got it? Okay. All of this now, 1 over the parentheses, they really don't matter in this case, right? 1 half, whoops, 1 over x, right? Minus 2 plus 2. You take a look, right? You have a minus 2 plus 2, those go away. And you get left with 1 over x. Let me write that a little nicer so it doesn't look so messy. 1 over x. I'm going to put parentheses around that one. And if you do this, right, this is equal to x. And that's it. Okay? That's all I need. So they're inverses. We're done. Okay? Like I said, just for kicks and giggles, we are going to go ahead and do g composed f of x. Okay, so this is the other way around. I'm going to grab all of f. I'm going to grab all of this and stick it in here. Got it? Okay, here we go. So I want 1 over, whoa, I went too far. I went too fast. See? 1 over, this all has to go into my x, right? So it's going to be 1 over x plus 2 on the bottom, minus 2. If you do this, the 1 over, right? This is going to be equal to x plus 2 minus 2. The parentheses sort of don't matter, right? And we have the thing again, minus 2 plus 2. Those cancel, you get left with x. Done. Okay? So, like I said, you could check one or the other. You can either check this one or this one, right? So long as you get x at the end, they are inverses. If you don't, they're not. Okay? Now, this is assuming that you do all your arithmetic and your algebra correctly, so just watch it. That's it. Okay? I've got a couple here that I want you guys to try. So we're going to do this in class. Okay? Determine whether or not these are inverses or not. Go ahead, try them for yourself. Okay? Some of these may not be inverses. Try it out. Okay? All right. Moving on. finding domains and ranges of inverse functions, okay? This goes back to my picture, okay? This will go back to my picture. So let me read it out really nice and loud, right? And then we're going to go through the picture, okay? So the range of a function f of x is the domain of the inverse function x, of f of x, f inverse of x, right? And the domain of f of x is the range of f inverse, okay? That sounds super confusing, right? So let's go back to my blobs, right? I'm going to draw two blobs. Okay, so over here, right? This is what we're going to call the domain of f, right? Okay, so we should be able to grab a point from here, right? Here's my point right here, x, right? And I should be able to take it to this other point over here, right? Which is the range of f, right? So I should be able to grab this point, hit it with a function, hit it in particular with f, right? And the outcome should be my y value, right? My y equal f of x. Yeah? Y, not g. Look at that. There we go. That's my y, right? So I should be able to grab an x value, hit it with f, and it should produce my y value, f of x. Yeah? All right. Now, inverse does exactly what you think it does. It'll grab this point, right? It'll grab your y value. Look at that. It'll grab your y value and bring it right back to x over here. So this, the green, should be my f inverse, right? Okay, and this sort of spells out why the statement is the way it is, how it's written up above, right? For f inverse, and I'm going to write this in green now, right? For f inverse, right, this over here is the domain of f inverse, okay? And all the outputs of f inverse are back over here, right, which is the range of f inverse. Okay, now I want you to take a look at what we just did, right? The domain of the domain of f just so happens to be the range of f inverse, and the range of f just so happens to be the domain of f inverse. See how the pictures make it make much more sense, right? Okay, that's what this basically says. Okay, okay. What ends up happening, sort of what people tend to remember, right, is if you have f and f inverse, right, the domains and the ranges flip. That's it. Okay. So suppose we had a one-to-one function f, right, and the domain is this, right, and the range is this. Find the domain and range of the f inverse. So if f has a domain of 1 to infinity, and a range, right, of negative infinity to negative 2, right, then for f inverse, the domain is going to be the flip. It's going to be negative infinity to negative 2, and then the range is going to be 1 to infinity. We are done. That's how simple this works. Okay? Okay. Moving on. Okay. This section right here is more with how to deal with and how to interpret f inverse, right? So, for example, right, let's say, in this case, we have a function ft, okay, that shows us our distance in miles, right, in a car that's traveled t minutes, right? So my input is t, my output f of t, my input is minutes, my output is miles. Got it? Okay, but now I want to do this. I want to interpret f inverse of 70, right? So just like I've been mentioning, right? F inverse grabs the outputs, turns them back into inputs, right? Okay, so in this case, right? I care about this column right here. Does that make sense? Okay. In particular, when we do F inverse, right? So notice how in this case, right? T is my input, minutes. My output is F of T in miles, right? When we talk this way, when we say stuff like this, we are now referring to the thing that's in the parentheses. It's the outputs of F, right? So in this case, my output is the 70. It's the 70 from the miles. Got it? So then F inverse of 70, right, is basically saying, right, up 70. What this is saying is essentially, right, how many miles were we driving when we traveled, how many minutes have we been traveling if the number of miles we've traveled is 70, right? So how many minutes traveled if we traveled 70 miles, right? And if we look at our table, right, F inverse of 70 is equal to 90. So we did, if we did 90 miles of travel, we were traveling for 90 minutes. Okay. All right, cool. Okay. Next example, we can grab inverses from functions from graphs themselves, right? So the first one is not bad, right? So let's go ahead first find g of 3. So this is telling us, right, my 3 is my input, my x value. What is my output? Okay, that is, and I'm going to go ahead and do this. I'm going to go ahead and do a purple point. We are looking at this point right here. So you guys see that for this one, right, the input is 3, right? My x value is 3. My output is 1. So equal to 1. Bam, all done. Okay, but now let's go backwards. G inverse of 3. Now this 3 that's right here, that is a y value this time. Okay, so for this one, we are going to be looking at a different point. We are going to be looking at this point. So see, for this point, the y is 3. It's asking me what my x is, right? And my x for this one is 5. Bam, bam, and I forgot to put the point for this one. Boom. Okay, hopefully this is making sense, right? So you know how a function works, right? Now you're getting to see how the inverse of said functions work. Okay, this is, at least for now, conceptual, right? We are going to get into how to find inverses for functions right now. Now, like I said previously, right? Does every function have an inverse? No. Okay, but when they do, right? This is the process to find them. All right. So the overall process to find an inverse, given that you have a function f of x, right, is these 3 steps. Okay. First of all, step 1, make sure f of x is a one-to-one function to start. To begin with, f of x has to be one-to-one. Okay. Next is you solve for x. Okay. And then the last step is, once you solve for x from step 2, right, you interchange the x and the y. Okay. This sounds pretty complicated. Okay. Some of you guys might have remembered how to do this another way. If you remember how to do that, how some other way from maybe kindergarten or high school, right? By all means, keep going at it. Okay. Just make sure it's somewhat it's somewhat equivalent to what I'm going to cover here. And for the most part, it's going to be. Okay, so just ask me during class. Okay. All right, so we've gotten to the good part. How to find an inverse for a function, right? How to find an inverse for a function that's been given to you. Okay, so step one. Let's say I wanted to find the inverse of this function. Okay. Step one, make sure the function is one-to-one. You can go ahead, grab this function, throw it into Desmos, right? Verify that horizontal line test works. And if it does, you are done. You can say it's one-to-one. Okay, so I'm going to go ahead and do this one-to-one by graphing. Okay, and I'm going to go ahead and show you guys how that works out. Okay, I'm going to go to Desmos. Bam. Okay, and I'm going to go to the graphing calculator. All right, and I'm going to make this, I'm going to do a double screen thing real quick. There we go. Okay, so type it in. F of x is equal to 2 divided by, oh, get rid of that, x minus 3 plus 4. All right, there we are. I'm going to make that small. There you go. So if you can see, right, every horizontal line will touch this graph only once. Only once, only once. So this is enough. This is enough to show me that you have a one-to-one function. Okay. Step two. Okay. I am going to solve for x. Now, the way that I'm going to do that is like this. Okay. I am going to, first of all, let me do 2 again down here, a little lower. Okay. I'm going to grab this and make it equal to y. So I'm going to do y is equal to 2 over x minus 3 plus 4. I just made this equal to y. That's it. Whoops, y. Got it? Okay. I'm going to solve for f of x. Do everything in your power to get x by itself now, right? Okay, so hopefully you guys have already noticed some stuff that we can do. Minus 4. So I have y minus 4 is equal to 2 over x minus 3. Okay? Okay, we're getting somewhere, right? When you have something like this, right, I can automatically do this. Y minus 4 over 1 is equal to 2 over x minus 3. And the reason why I do it that way is hopefully this triggers something in some people, in some of you guys, right? That we can go ahead and cross multiply at this point. You guys see that? Cross multiply, cross multiply. Okay. So then I have this now. If I cross multiply, right? Y minus 4 times x minus 3 is equal to 1 times 2, that is 2. Okay, now remember, we are looking for x by itself. Okay, we are looking for x by itself. We need this by itself. So I can go ahead and grab the thing that's to the left of it, all of that, and get rid of it. It's being multiplied, so I can divide. So I can go ahead and do divide y minus 4, divide by y minus 4, right? This cancels this. I get left with this. X minus 3 is equal to 2 over y minus 4. Okay, and now if you guys see, there's a minus 3. I need this still by itself, still not by itself, right? So plus 3, right? Plus 3 over here. X is equal to 2 over y minus 4 plus 3. Okay? And I'm going to grab this, and I'm just going to move it over a little bit because I kind of want to use up the rest of the space here. There we go. Okay. The last step, that was step 2. Step 3 is just interchange the x and the y. So y is equal to 2 over x minus 4 plus 3. We're all done. F inverse of x is equal to 2 over x minus 4 plus 3. Boom. So what we just did, right? What we just did is this. We were given a function, our original f of x, right? We found its inverse. This is the inverse for it, okay? So whatever f does, this new f of x that's highlighted in green will undo it, okay? All right, awesome. Moving on. Find the inverse. I'm gonna make you guys find inverses, okay? There's 4 of them. You only have to do the one, and we'll assign the numbers when we get to class, okay? Now, there is something that I said we need to clean up, okay? That f of x has to be 1-to-1, right? F of x has to be 1-to-1. Okay, so this is this example. This is going to show you guys why we need to clean stuff up, okay? So let's go ahead and take this function right here, okay? Hopefully, you guys remember, right, how this graph looks like, right? So I'm going to go ahead over here, and I'm going to plop it down really quick. I'm not going to use Desmos for this one. So hopefully you guys remember, right, okay, that this is going to be a square root function, right? So one of those single swooshes, right? I'm going to move it over to the +4 and up 2, right? So this is what it's going to look like. 1, 2, 3, 4, 1, 2, right there, and then it's going to do a swoosh from here. So it's going to do something like this, whoosh, right? Okay, so we have a graph for it. We know we can picture it in our minds, right? Okay, so looking at f of x, right? This is my f of x. Looking at f of x, we can tell what the domain and what the range is going to be, right? So my domain should be, looking at this thing, right? It should be 4 to infinity. And I'm going to include the 4. Okay, and my range should be 2 to infinity. I'm going to include those 2, right? All right, we're going to go through the process now of finding f inverse. Okay, so same process. We can tell from the graph, right? It's 1-to-1, so let's go through the steps. So number 1, right? F is 1-to-1. We're good. Okay, so now step 2. Step 2 said I need to solve for x now, right? I'm going to go through the process. Y is equal to the square root x minus 4 plus 2. All right. I need to solve for x. Remember that, right? I need to solve for x. So minus 2, y minus 2 is equal to the square root of x minus 4. Okay. Hopefully you guys remember. In order to get rid of a square root, you must square it. So I'm going to do this. I'm going to square, right? So then this cancels the square root there. I get left with this. Y minus 2, all of that squared, is equal to x minus 4. Okay, last step, I need x by itself, right? I have a minus 4. I'm going to do plus 4, okay? And that, let me scroll this down a little bit. Okay, that should be x is equal to y minus 2 squared plus 4. So then therefore, f inverse of x, if you do the flip the x and the y, right, you get is equal to x minus 2 squared plus 4. Okay? Yay, we're done. Not quite. So I'm going to highlight this because this is our inverse. Okay? But, so remember when I defined it way at the beginning, right? Both of these have to be true. F composed F inverse of x is equal to x, and F inverse of f of x has to be equal to x. Both of these have to be true, right? Okay. Remember from the get-go, right, that f of x, the f, the one originally, right, had to be 1 to 1. Got it? Okay. If we computed f inverse, right, so this is, I'm gonna point these out, right? Both of these two functions, right, they're inverses of each other, right? So if f of x was the function that we had, f inverse is the one that's below it in green, right? And likewise, this is the catch-22, right? And likewise, if we're messing with f inverse, then f is also the inverse of the inverse. So the definition for the inverse also applies to the inverse function itself. Okay, which means f inverse needs to be 1 to 1. So both functions, f and f inverse, have to be 1 to 1. Now you probably thinking to yourself, all right, that is a catch-22, but what's the difference? We already have f inverse, right? There's a problem with this function. So let's do the same thing that we did before, right? I'm going to go ahead and graph it. Okay. Hopefully you guys see it already. What's the graph of this look like? It's a parabola that's been moved over to the positives by 2 and moved up by 4, right? Okay. So this is our graph now. Let me actually move this over a little bit. So moved over by 2, 1, 2, and moved up by 4, 1, 2, 3, 4. I'm going to make this a green dot now. And this is a parabola. It's not flipped, right? It's not shifted any more than what's already there. So this graph is this. Whoosh, whoosh. You guys see it? You guys see it? This function right here, this is not 1 to 1. It does not pass horizontal line test. It does not pass horizontal line test. So how do we reconcile this? The answer is honestly much simpler than people are making it. Okay, we are going to slice f inverse of x in half so that we do get 1 to 1. So what does that? It literally means exactly that. We grab this, we slice it, and we say we don't want this portion. We want the other portion. We want this half. We want this half. Okay. Got it? So then by doing this, now we do have f inverse being 1 to 1. What we call this, what we say here, is that we are restricting the domain of my f inverse so that I do have a true inverse of f of x, so that both satisfy the definition of an inverse. Okay, so my domain of f inverse now, right, is, and I'm going to do in range 2, the domain, right, the domain of f inverse is going to be 2, and it's going to be closed bracket, right, 2 to infinity, and my range is going to be 4 to infinity. Okay, and this solves something else that hopefully you guys should have realized as well, right? Back from our picture and back from our definition, right? If this is my domain and this is my range for f, then the domain and the range of f inverse should be these flipped, right? That got taken care of by slicing our f inverse in half. We now can call these both f inverses of each other, right? Okay. So that's why we say we have to restrict the domain of f in order for it to be a true inverse. Or sorry, of f inverse in order for it to be a true inverse of our function f. Okay. Whew, that was long. All right. I believe right after this is our lecture questions. If you have any questions about how f or f inverse work or how they relate to each other, ask me during class. We're going to go through those quick checks during class. Yeah, besides that, happy studying.